So in week 1, lecture 5, we talk about logical expressions. Logical expressions are really what set computer languages apart from arithmetic. With logical expressions, you get the computer language to do a whole variety of different things. The crucial concepts here are the keywords true and false.
Now we move on to the heart of computing, which is logic. After this lecture, we'll be able to talk about logic, in particular about the keywords true and false, and about logical operators. In particular, we will be able to form logical expressions using the operators not, and or. The first thing is for us to pay careful attention to computer logic. Logic can be defined simply as the study of how to transform true sentences into other true sentences. There are two famous examples I want to stress. The first is Socrates is a man, all men are mortal, therefore Socrates is mortal. The second one is if it rains, the grass is wet. It is raining and therefore the grass is wet. Logically speaking, these are somewhat different forms of reasoning, and in computers most of the reasoning we want to do is in terms of if statements, such as in famous example 2. It may be that you think that working so rigidly and formally as is given in these two examples is inadequate, and in many cases in the real world it is inadequate, but a computer program cannot do otherwise. Computer logic can only evaluate logical expressions. We will see exactly what that means. In Julia, as in most computer languages, there are only two logical values, true and false. They are Julia language keywords. Their meaning is fixed. You cannot change them. They mean in Julia pretty much what they mean to us in ordinary life. And if you try and think about statements in Julia in terms of what you know about a statement being true and a statement being false, then most of the time you will get it right. So when we want to work out what to do with true and false statements, we want to combine them. There are many operators in computer languages in general and in Julia as well, but three of them really stand out. The exclamation mark, which is the not operator, the double ampersand, which is the and operator, and the double vertical line, which is the or operator. Let's start with the exclamation mark. It changes the truth of whatever it is applied to. So now we have the value here, true, and we apply the operator exclamation mark to it, so the not of true is of course false. Similarly, the not of false is true. Okay, so the not operator operates on a single expression which is either true or false, and it changes its value to the other. If we have two logical values, P and Q, and they could just be true or false, or they could be complicated expressions which evaluate to true or false, we want to combine them, and the AND operator makes a compound statement which is true if and only if both parts are true. So here we see that we have the value true, we combine it via AND with the value true. This is a compound statement. It is true only if both parts are true, because this is an AND. And of course, if both parts are true, it is true. If only one part is true, it is false. It doesn't matter whether it's the first or the second part. And just to be complete, if both parts are false, then of course it must be false. On the other hand, the OR operator needs only one of the parts to be true. If we say, for instance, black is red, or Julia is a language, well, that is of course true. But if we say 1 and 1 is 70, or 10 divided by 2 is 0, both of these parts are false, and so therefore the combined statement is also false. So the OR operator makes a compound statement that is false if and only if both parts are false. let's confirm that in detail, one after the other. So here both parts are true, and so therefore, obviously, it's true. Similarly, if one part is true and one part is false, then it's still true, and it doesn't matter which is the first or the second. And finally, if both are false, then, and only then, is the compound also false. Let us just relate this to real life for a moment. We often take a reasoning like this. You stand on the station platform and you say either the train is late or the station clock is wrong. We would then hope to eliminate one of them. So for instance, if we're actually hoping that the train is late because then it might still come and we can actually get on the train to get somewhere, we would then hope to eliminate that the station clock is wrong. If we do that, we then reach the conclusion, oh well, the train is late. But that only works if at least one of them must be true. So we reason correctly only in the case that they are not both false, and that's exactly the definition that we gave to the operator. The OR operator makes a compound statement that is false even only both parts are false. In Julia, as in most computer languages, to create a value which is true or false, we very often use comparison operators, and in fact very often use it on numbers. After all, Julia is a language specifically for numerical computing. So 1 less than 22 is obviously true, we see that. Minus 10 greater than 3 is obviously false. And the double equation. Now we've already seen that a single equal sign is the assignment, and it gives the variable on the left the value of whatever is the result of the expression on the right. Here we have the double equation, and this is a test for whether the left-hand side is equal to the right-hand side. In this case, it is obviously true. Make sure that you are very familiar with these comparison operators because they are used all the time in writing programs, and in fact, you should also get hold of the other comparison operators such as less than or equal to, and so on. Now, when writing computer code, we often combine these operators in quite complicated systems. So above we had the example 1 plus 1 is 70, or 10 divided by 2 is 0, and here is an even longer example, which is 3 minus 4 is greater than 1, and 2 plus 2 is equal to 4, or 10 minus 5 is greater than 2. This is an example of how you can make things hard in computer programming. I did say that computer programming in Julia is easy, and it is, but even in Julia you can make things hard. In any computer language, you can make easy things hard. So, if I look at this expression I've written here, what happens with Julia is that it first adds these parentheses to separate out the expressions that are being logically compared. This is then evaluated to see whether it is true. This is evaluated, and perhaps this is evaluated. So, if we do this, we see that 3 minus 4 is minus 1, so this is false. 2 plus 2 equals 4 is true. 10 minus 5 is greater than 2 is also true. Now, we combine these. So, if we do that, then that's what we get. So, to be exact, arithmetic operators have a higher preference. So first Julia does the arithmetic and gets false, true, true, and then evaluates it. Let's see if we get the same result in both cases, true and true. This is true because false and true is false, and then false or true is true. This actually works whether we read it from the right or the left. Here's a very important bug hunting tip. In Julia, there is another set of operators which are based on a single ampersand and a single vertical line. They're quite different. They don't work on Boolean values. Boolean values are things that are either true or false, and that is where the operators or and work on. Single ampersand and single vertical line are bitwise and bitwise or, and they operate on integers. In fact, the integers are first expressed in binary digits, and then they are bitwise and, for instance, then goes binary digit by binary digit and operates on both integers like that. This can be a hard bug if you have used a single ampersand when you should have used a double ampersand. Then you may find it very difficult to spot that this is a mistake you've made. And it's unfortunately part of computer programming that you really have to learn to get the skill and the patience to find errors like that. In Julia, there is a strong type system, very detailed, which will usually detect that you're attempting to use, let's say, a bitwise operator on a Boolean value and warn you, and vice versa, but unfortunately not always. When your code is running and you get strange values but not actual error messages, one of the possibilities is that you're committed to bitwise for Boolean bug.
So, that's logical expressions. You should go away and practice using logical expressions. Remember that competence with logical expressions make all the difference in writing your computer programs.